Here we are going to see the demo of a measurement of linear displacement using LVDT. In this circuit, we have used here XR2206, that is for generating a sine wave as a here at this point. Here we will get the sine wave as a signal at this point and frequency of 1 kHz. That is with respect to the primary of LVDT. So for generating this, we have used various components at this point, and with the help of this amplitude and frequency plot, we have to set the sine wave as a, with the help of the frequency we will set it as a 1 kHz, and this amplitude plot should be at the maximum position. So for that we will get the proper output at the final. And here it's the secondary portion of the LVDT, that is here we have to connect the sensor. This is the LVDT. That sensor we are going to connect at this point is here, and with the help of this, here at the secondary portion, that is whatever will be the changes we are going to do with the help of this LVDT. Means whenever we push it to the inner side, so it will get some changes. So that changes you can see at this here, this test point, that is we will get in the waveform form. And in LVDT there are usually three positions, that is whenever you will keep it at a middle position, that time it will show as a 0, and when you will push it to the inner side, that means when your LVDT goes to the side, that time you will get a positive, that is till plus 10 millivolts we have adjusted as a final output. And when you will keep it as a outer portion, so that time you will get as a minus voltage at this point. That is at this 10 I will get as a 0, and at this 0 I will get as a plus 10 volt, 10 millivolts, and at this 20 I will get as a minus 10 millivolts, and that voltage will be displayed at this display, that is it is in the digital form. So here you are going to see voltage whatever displaying here, and this is the output final which is connected to this one. So first of all we will switch on the unit, and we will see the waveform across the primary section, that is of the sine wave, that is without connecting the sensor to this point. Here you can see a 1 kHz sine wave electrical. With the help of this you can vary the amplitude. With the help of this you can change the amplitude, but keep the amplitude position at the maximum so that output will be at the proper. And see here you can see here the frequency, that is 1 kHz that you have to set for this one. Now I will see to the primary secondary of LVDT. So for that we have to connect the sensor here, and also see the waveform across the differential, that is here. With respect to both this we will see. Now first I will adjust this LVDT to the 0, that means then it will come to 10. That time it should get 0. So you can see at the 0 portion it is there. And now here you can see the, that is this waveform, it is a differential waveform, and this is the secondary of LVDT. So whatever will be your changes, that will be shown on this waveform. So you can see as I have set my LVDT to the mid position, that is at the 0. So you can see here I am getting, it's not a 0, it's here I am getting some voltage, that is a residual voltage. You can see you will not get a 0 voltage at this point. Now as you vary this, means you will push it to the inner side, so you can see the voltage increases at this point. You can see the amplitude increases, and also you can see as you are varying this, so your display changes the same whatever will be there, same you are getting at that point. See here, as I have set it to 5, so you can see here 5 millivolts. Again if I will vary, okay, to set such that at 0 I should get a plus 10 millivolts. So at 0 I am getting 10 millivolts. And also you can see the waveform, that is the amplitude got increased, and this waveform is constant. Means it will change, but it will change very slightly, so you can see that changes. As it is, the windings are the common, so that's why not getting that much changes. Now we will see it at the minus point, that means we will vary to 20 volts. So when you set to 20 volts, see below the 10 volts I am getting it as a minus, so that is minus 3.6. to vary to 20, so we have set it such a way that at 20 we should get a 20, we get a minus 10 volts, minus 10 millivolts, that is terminal to minus 9.1. So here you can see the waveform, that is approximate to, no, it's not that much, means your voltage gets decreased as compared to when it was in the positive position, and here also. So in this way you can take the readings for 1 volt, 2 volt, 3 volt, and also you can note on the waveforms as per given in the manual, you can see. And hence in this way we complete the demo of the measurement of linear displacement.